everyone. An arrow is launched upward with an initial speed of 100 meters per second. The equations above describe the constant acceleration motion of the arrow, where v sub 0, same v subscript 0, is the initial speed of the arrow, and v is the speed of the arrow as it's moving up in the air. H is the height of the arrow above the ground. T is the time that has elapsed since the arrow was projected upward. And G is the acceleration due to gravity, which is 9.8 meters per second squared. So we'll get started. Just remember this part here and answer a few questions. So the first question is, what is the maximum height from the ground the arrow will rise to the nearest meter? So what we know is that given the problem that we need the maximum height, so we're going to use this formula here. Set velocity 0, because remember maximum height, at maximum height the velocity is 0. So we're going to set v to 0. Our initial velocity is 100 meters per second squared. And then our g is that 9.8 meters per second squared. This is just not squared, this is just second. And then times time. So the first thing we have to do is solve for time. When we solve for time, we're going to add 9.8 to both sides of the equation. So you get 9.8 meters per second squared times t equals 100 meters per second. Then divide both sides by 9.8. And divide by meters per second squared. And you'll end up getting, basically you're going to get t equals 10.204 meters per second. Now once you have your t, we're going to go back here and fill in that. So let's do that. Our height, because that's what we're looking for, our height is going to equal 100 times 10.204 minus 1/2, and I'm not running out of room here, so minus 1/2 9.8 times 10.204 squared. So that's the whole equation. And when you put that in the calculator, you're going to get H is approximately 510. All right, now that we have that, we have one more question to answer. So the last question is, how long will it take the arrow to reach its maximum height? So what we're going to do is take our second equation and plug that in. So we get 510, which is our height, equals 100 times t minus 1/2. Remember, g is 9.8 meters squared. Let's put 9.8. And then we're solving for t squared. So this equals 510, 100t minus 4.9 t squared. Now I'm going to move everything to the left side of the equation. You get 4.9 t squared minus 100t plus 510 equals 0, and we're looking for the time, so the nearest second. And then I put this in the calculator under y1, and then I did, so I put it in the calculator, I did second graph, and I'm looking for where y equals 0. And when you find that, you will get your x. Make sure you're in decimal form. You have it at least to the nearest tenth. You will get x equals 10.2. Or you could say t, because that's really our t, equals 10.2. So you need to use a calculator on this. Or what you could have done is taken our original, the second equation here, and plugged everything into that. So velocity, let me do it in red, velocity squared equals 100 meters per second squared minus 2 times 9.8 times your 510. But then you would have had to add back your original velocity, which is 100. So this amount equals 4, and our initial velocity is 100, and that's your VT, so V squared, sorry. So you take the square root of 104, and that's going to be approximately 10.2. And I don't know why I keep calling my 2's t's, but so this is 10.2. And that's it. Thank you. Have a nice day. Bye-bye.